Everybody knows how to stage files in Git, right? First we create a file, in this example fruit.txt, and then git status will tell us that we haven't staged the file yet. How does Git know that? If we peek into the working tree, here's our new file fruit.txt, which you can quickly see. But if we peek into the staging area, we see no entry for that file yet. That's how git status knows it's a new file. Okay, so let's stage the file. Okay, and now git status should no longer complain. It simply says we haven't committed the file yet, but commits are not the topic of today's video. Okay, and then inside the staging area, we see there's a new entry. You can see it right here. Okay, and the question of today's video is, can we somehow sneak a new entry into the staging area for a file that doesn't even exist in the working tree? Okay, and to do that we have to understand this line. So these are just standard Unix file permissions. This is a hash for a blob in Git's object store, and this is a file name. Okay, hash for a blob in Git's object store, what does that mean? It means inside Git's hidden directory there is a file for the object store, and there should be a subdirectory called B9. This is a directory that's hopefully B9 to us. And inside that there should be a file with this name starting with C22. And indeed, here we can see the file. Okay, and if we peek into that file as if it were a text file, we don't see interesting info because it isn't a text file. And if we look at the hex dump, again, not particularly revealing because this is output from the zlib compressor. All of Git's objects are compressed on the hard disk. Okay, so how would we uncompress it? That would be zlib-flate uncompress from that file, and that looks more interesting. So here's our actual content prepended with the words blob space and then the length of the content. And in case you're wondering what would happen if the content also starts with a digit, how would Git disambiguate that? Let's pipe the last input into HD. Here you see there's an invisible character between the header and the content, which is the good old null terminator. Okay, cool. Right, so if we look at the staging area again, now our job is to insert a new line. So we do that in 2 steps. The first step is store another blob in Git's object store and then link to it from the staging area. Okay, so how do we create a new blob? Let's say my favorite planet is Earth. Then pipe that into git hash object standard in write, which gives us another hash, which means now there should be a directory 2f with a file d6d and so on. Let's quickly confirm that. So objects and then 2f, d6d, indeed, here it is, right? And if we want to see the contents, there's a shortcut in Git. You can simply say cat file pretty print and then 2f, d6db and so on, and here's our content. Okay, but git status doesn't know anything about that yet, and inside the staging area, of course, there's still no entry for that. Okay, so let's make an entry. So that would be update index. We want to add a file, and the cache info is the Unix permissions, then the hash, and then a file name, let's say, I don't know, planet.txt. Okay, and then if we look at the staging area again, now we have indeed successfully sneaked a new entry into the staging area for a file that never existed in the working tree, right? So git status tells us, right, you have successfully staged the file, but it appears that after staging the file, you have deleted it from the working tree, when in reality it never existed, right? You can see no such file in the working tree. If we wanted, we could copy the file into the working tree with the restore command, git restore planet.txt. Now Git is no longer confused, and inside the working tree the file also exists, and we could confirm that with a simple cat command. Okay, maybe let's do it one more time for good measure. So let's say test123, pipe that into git hash object standard in write. We get back a hash, and then we update the index by adding a new file with these file permissions, the hash, and some arbitrary name. And then if we look at the staging area, again, we have successfully sneaked an entry here, and git status tells us indeed we have staged the file, but it appears to be gone from the working directory. Okay, and in older versions of Git, git restore doesn't exist. You would do it with git checkout --. Okay, and then we see the file exists. We can confirm that, and Git is happy. Okay, so I hope this gave you a better understanding of what the staging area really is. It's basically just a long list of file permission, hash, and file name, and those hashes refer to blobs stored in Git objects, then this directory name and this file, and it's just a zlib compressed file consisting of a header and the actual content.